Good morning again. Thank you for coming to our session. I know you could have gone to any other session, but I'm really glad that you're here to listen to what we have to say about scientific data. So I'm Nawajish Noman, and my team member Sharmishta Chatterjee. We work for Spatial Analyst team or Multidimensional team, and we work on a bunch of stuff. However, today we're going to talk more specifically about scientific data, multidimensional scientific data. So let's get started. What am I going to talk about it? First, I'm going to define what do we mean by scientific multidimensional data in the context of ArcGIS, right? Because, everybody has their way of defining it, so we'll talk about that. And then we will talk about how can you read this data in ArcGIS. Read this data, not convert. Read this data directly in ArcGIS, and how can you manage them. Then we're going to talk about analysis and visualization, because we are from a geoprocessing team, analytical team. To us, GIS is more about analysis. The more we can do, the better it is, right? And then we'll talk about how you can actually extend your capability, analytical capability, using Python and something else. And then, how can you share your work with your colleague or rest of the world, and then let them do something better with your data. So let's get started with the definition. So scientific multidimensional data is scientific multidimensional. Well, obviously, it has to be multi-dimension in nature, which means probably in addition to X and Y, it have other dimension, maybe time, maybe depth, altitude, some other dimension. But when we say scientific data, we are specifically referring to three formats: netCDF, GRIB, and HDF. Those are the format we kind of call scientific data. And some of the examples are ocean data, sea temperature, and we will show you some of data, weather data, land surface data, bunch of other data. A lot of this data fall into this category, and a lot of model output also actually fall into this category. So we want to use this data in ArcGIS platform. Now, we talk about platform a lot, and different people look at it and kind of understand whatever the platform is. I have my definition, which is supposed to be the same definition, but the key component here is that we not only have desktop to work with, we also have this notion of web GIS, where we have server and we have online content, and we're serving this data. And people from the other side, whether it's a desktop, from web or other devices, from all this client, they can access this data. So our objective is to work on this platform with this data, like any other GIS data that we have. So if we summarize that objective, what are the key things we are trying to do? What are the key vision that we have? And interestingly, this vision is no different from other vision that we have with any other data, any other GIS data, right? So we want to do reading, direct ingest, not conversion, directly read that data. We want to manage it. We want to visualize it, explore it. We want to analyze with it. And then finally, we share it so that the cycle keep going on and on and on. And that's what we want to do with our GIS platform. Now, how can we read this data, ingest this data? There are a couple of ways, and my colleague Sharmishta will show you how to go about it, right? We have a toolbox called multi-dimension tools, and you can use this geoprocessing tool to read it. But we also have other ways to do it, so we will show you. We are writing again and again, are pointing out that we directly read. That means when you are reading this netCDF or GRIB or HDF, there is no conversion going on, directly reading it. We can also ingest OpenDAP service, and some of the organization actually serve OpenDAP data or rely on OpenDAP data services to do it. And We also support these formats like netCDF, HDF in Mosaic Dataset. That's another way of not only reading it or organizing it, that's also an interesting way of doing many other things which we'll discuss later on. In Pro, we have done something more, because every time I ask somebody to run a tool to read netCDF files, they said, oh, why is that? Because all of that data I can drag and drop. Of course, we can drag and drop netCDF, but we also do add data and then do it. Why could not we do it? There are reasons we could not do it. There are reasons we did not want to do it earlier, but you guys have been asking for years. So we said, hey, why not? Let's do it. So from add data, now we have multidimensional raster layer dialog, which will bring up a dialog, and you can read data from it. And Sharmishta will show you how to go about it. Okay. Now, a couple of quick points before we start to see ArcGIS Pro in action. If we look the netCDF file format or HDF file format or GRIB, that's a very powerful file format, very flexible file format. Well, flexibility always brings some additional headache, right? Because everybody can write their own way. Now, when we are reading it, how do I know what to read, right? So we need some direction. We need some roadmap. And CF convention is our roadmap. So when we crack open the file, we look at it and say, this means, this variable means this dimension means this, and all these things is actually defined in CF convention. The reason we use CF convention, there are a couple of key reasons, but most important thing is it's initially developed for climate and forecast data and all this data, which most of the time we're trying to use. And another important thing is it handles the coordinate system. Because we are GIS company, we are dealing with GIS data, and the objective is to you bring in this data, combine with other GIS data to do something. So if we cannot handle the coordinate system, then we cannot really work. So that is why we actually chose CF convention. And current version, we're working with current version, you can go and take a look at it. And whenever we say, somebody say, I have an netCDF data, the next question is it CF compliant? I go like, what? So that's always an interesting discussion, right? Now, we talk about this coordinate system. There are key things I want to mention, that we support geographic coordinate system, we support project coordinate system, and in your file, there are certain ways to define it, and it is already there or not. And we actually look at some of the key information, and based on that, we decide whether it's a geographic coordinate system or a projected coordinate system, or if it is a projected coordinate system, what projection you are using. All this information are defined, and we follow this standard CF convention and read it. It looks for units, or for PCS, it looks for some standard name. And all these things are defined in grid mapping variable, which is discussed in Appendix F in CF convention. We also support P string, so when we write P string, and we are also going to support few other things. So now we talk about ingesting this data in separate file, but hey, if you look at your output, there are many files sometimes, and model outputs are from one region here, another region here, another region here, and sometimes your time steps comes in separate files. When I saw that, I said, why somebody is writing it in separate files? There is a reason. They want to create small data, they want to pass back and forth over the net. There are many reasons why it happens. So we wanted to solve this problem so that you can put them all together but still use it as a multidimensional cube. And that problem is solved by using Mosaic Dataset. So Mosaic Dataset lets you do that, and we'll talk some more about it. But when we solve that problem, it also gives us additional flexibility that Mosaic Dataset brings on the table. What are those, right? It does the spatial or temporal aggregation, but it also lets you do analysis on the fly because you can apply raster function to it. We'll talk about that some more down the line. And then you can turn around and you can serve it as an image service, map service, or WMS. Some of the direct benefit you get is it's a direct ingest. It eliminates data conversion, eliminates data processing, improves workflow performance, and integrate with service-oriented architecture. That is why using Mosaic Dataset is very powerful. So with that, I'll hand over to my colleague, and she will show you how we ingest scientific data.
Can you hear me? No? Now, can you hear me? Cool. Thank you, Norman. Norman already discussed about reading and managing scientific data. Now let me show you how to actually do it in ArcGIS Pro. We have all our netCDF tools under the multidimensional toolbox. There are 3 types of tools here. The 4 make tools allows to read scientific data. The 2 netCDF file tools allows to write to the netCDF files. And the select by dimension, the last tool, this helps us to see certain slices. I have this HiCom dataset downloaded from NOAA website, and I am interested in water temperature variable, which I know is gridded data. So that's the reason why I'm using the netCDF raster layer tool. I'll select my variable. As soon as I select my variable, the x and the y dimension get populated automatically. With everything else as default, I'll run the tool. This outputs to a raster layer of water temperature for region 1. You can also do this using the Python. And here you can see the tool signature. The only thing I'm changing here is I'm doing it for a different location, but with the same variable. So this gives me the water temperature of region 7. Now for this tool, we have a newly added parameter, which is cell registration. This is an optional parameter that we added in Pro 2.3. And this parameter controls how the raster cell is registered with the x and the y coordinates. Now let me show you how that works. By default, a cell is registered at its cell center. But if I select the lower left option, it will get selected in the lower left corner of the cell. Similarly, if I select upper left, the cell will be registered at the upper left corner. As Norman has already showed you, or actually told you, that you can add data using the Add Data dialog, add scientific data. Let me show you how to do that. Here we can ingest netCDF, GRIB, or HDF formats. I'll use my previous data set with the same variable. An additional thing that you can do from this dialog is you can interpolate gridded data if it's irregular, so if the delta x and the delta y are different. So this is my newly added raster the raster layer for water temperature. Now we know that all our data cannot be gridded, and we do have irregular data. For example, station data or data that moves over time. So in such cases, what we will use is make netCDF feature layer tool. For example, I have this underwater glider data in which I'm interested in the salinity values. So that's what I specify as my variable. And one thing that I'm doing differently here is I'm specifying my row dimensions to get the values for all the points. I've already run this tool before, and this is how all the points look. This is the full glider path that shows how the glider has moved and how salinity changes. You can also take a closer look by looking at the table output. In my earlier section, I've already showed you that I had to run the make netCDF raster layer tool twice to do this section. Now, this is not very practical when I'm working with multiple files and I want to look at larger areas or time steps. So how do I manage that if I want to see a seamless continuous layer? So that's when I can manage it using a Mosaic dataset. So to create a Mosaic dataset, I'll use this tool create Mosaic dataset, where I'll give the output location, I'll give the name, and I'll specify a coordinate system. To that, I'm specifying my netCDF files. Here I am interested in 2 regions, region 1 and region 7, and for each of the region, I have 3 time steps. So that's why I have 6 files. My raster type is netCDF, and I've specified variable water temperature. With that, I run the tool, and this is how my output looks. See how seamless it is? I don't have to do it more than once. However, for creating Mosaic and doing it from the UI, it's not always, like if I have to deal with multiple files, it's not always helpful. So if I can automate this, like for a lazy person like me, I would like to just automate it, and that's so much easier to update it, or if I have to do it frequently. So I'd written a script for that. So in this script, I'm basically doing the same thing. I'm first creating the Mosaic dataset, and then I'm adding all my rasters to it. Something interesting that I've done in this script, which I've not shown it from the application, is I'm specifying a processing template. In this processing template, I have selected only 2 variables. I'm using the U and the V component to look at ocean currents. So if I run this script, this is how my ocean currents are going to look. So far you have seen how to ingest netCDF raster layer in 2 ways, feature layer, and how you can manage multiple files using a Mosaic dataset. Over to you, Norman.
Thank you, Sharmishta. So Sharmishta already showed you, how easy it is to read netCDF file or multidimensional file, whether it's a raster or its points or glider path or the trajectory, things like that, right? And when things get a little complicated, bigger, too many files, you just throw it in a Mosaic. 2 simple steps: create it, add files to it, there you go. You can use it. Now that you have actually read the data, what are the things you want to do? You want to display them. So just more than looking at the picture, you want to probably poke around, and explore it closely, or change slices, things like that. You may want to create a chart, or you want to animate, or you want to analyze it so that you can find some valuable information, create new information product, or impact, stuff like that, right? So let me go through some of the simple things that you can do. Like when we talk about visualization and exploration, what do we want to do? For multidimensional data, it's obvious that we want to slice them, right? We want to look at different slices with a different time step or value at different depths, right? Slicing. We also want to see how it's changing over time, either step by step or animate through it. We also want to actually look at other dimension. So this is kind of interesting, right? A couple of years back, 9.2, 9.3, we had a way to look at different depth, but with the new time slider, we removed that capability. Sure enough, you started to notice that and say, hey, why can't I move through depth? So now we have a new slider called range slider. The reason it's a range because it can do multiple things, but for this context, we're talking about looking through other dimension other than time, right? Any other dimension other than time, you're going to use range slider. Now, Sharmishta already gave you a sneak peek of how to look at vector field, right? The ocean current. That is actually another interesting story. The data that you're looking at is actually a raster data, it's gridded data. However, one raster coming with U component, another raster coming with V component, or there could be another combination. One raster coming with direction, another one coming with magnitude. Now you need to combine these 2 information. This is where she actually used the template. Now when you combine that information, then you get your actually vector, right? And to visualize it as a vector from raster, we have this predefined renderer. This is what you can use. If you have done this work before, it was actually a very painful work, because what we had to do, we had to actually create points out of this, combine this information and symbolize it. Somebody's shaking head over there. So people who have done it know how painful it was. Now it's much more simpler to do, right? So sometimes we try to listen to you guys. Most of the time, we don't always get to do all the things that we want to do. Another thing is changing slices, right? Without changing slices, looking at multidimensional data is useless, right? And there are many ways to do that. We actually have now many more ways to do that. Earlier in desktop, we had layer properties. In Pro, we don't have that because we actually have a better way to do it. We also have select by dimension tool. That tool we use when we're trying to do analyze or because or automate the process. If you're trying to do it interactively, there are easier ways to do that, and Sharmishta will show you that, and I just want to give you a sneak peek of that. Like say, you want to go step through time. What are you going to do? You're going to use time slider, set it up, very easy to set it up, and then you can go one step at a time, or whichever step you want to jump around, or you want to find out where things are changing. You just animate and look at it and say, oh, this is where I want to take a closer look, and then you go there, right? Same thing with the depth. Right? You want to look through it. So just so that you are not confused, we said the time slider will show up at the top and depth on the side so that you don't confuse with each other. However, this is the range slider, and you can actually specify everything and look through different slices, in different depth. Same thing can be done for altitude, right? We already mentioned about the predefined renderer, where we support U and V, or direction and magnitude. And if you're familiar with this data, it comes in two different flavors, right? And not only that, to make things a little bit more interesting, sometimes it actually going to or coming from, there's kind of other discussion going on. And then sometimes you have too many data points that you don't want to visualize when you are zooming in or zooming out. So we actually have ability to resample it on the fly. So if you look at it closely, you'll see it is doing a lot of good things. It is not only combining this information on the fly, it's letting you do some of the quote-unquote analysis on the fly by doing resampling, and you can specify how many points you want to see or not see at a different zoom level. So you can do actually some vector calculation. This seriously eliminates some data processing and actually simplify the process. I mean, seriously. And that's not the only thing we want to do. We want to do something more, right? Which is, we want to poke around and see how things changing, right? One of the most common thing people want to do is time series, right? Everybody wants to do time series, one some form or the other, right? So now we have added a new functionality where you have a hypercube or 3D cube, and you can poke at a point and say, give me all the values I want to see. So, and Sharmishta will show you, not only you can see the time series, you can actually do some cool calculation with it, analysis with it. Now, now step back for a second. I said, when we started, we talk about multidimensional tools, and one toolbox, only 7 tools, and then some dialogue, and I'm talking about profiling, charting, and I'm talking about analysis. You might say, oh, where is those tools, right? I don't see any multidimensional analysis tool or anything. So where is it coming from? Well, if you actually think we have all this toolbox full of analytical tool, and what we wanted to do is we wanted to take advantage of all those tools with scientific data. The only way we could do it if we start to recognize scientific data like any other raster, feature, or table. So if we go back all the way to our make tools, it says make netCDF raster layer, make netCDF feature layer, make netCDF table view. So from the get-go, we are turning this either a raster or a feature or a table. The moment we do that job, then guess what? All the tools that are suitable for raster, feature, and table, you can use those tools to do that. So that's how we're actually connecting the dot and then opening up the possibility of doing all sorts of analysis with all the hundreds of analytical tools we have. So this is how we can actually do it. And Sharmishta will show you how to do some of it. Actually, this is a model I did actually probably 15 years back. like or early to, yeah, almost like 12, 13 years back, and still I use it because it's kind of an interesting that how we can do some complex temporal analysis just by using the tool we have in the model and put it in the model builder, right? And so you can try some of those things actually. There is another thing that we can do is we can use on-the-fly function, raster function, to do on-the-fly analysis. Why on-the-fly analysis is important? Okay, what is the temperature today in Kelvin? Kelvin? But if you actually look at the model output and everything, temperature is in Kelvin, right? And if you try to communicate that in Kelvin, it's not going to go well. You know, somebody will understand centigrade, somebody will understand Fahrenheit, and they said, oh, today is this much Kelvin. It really doesn't fly, right? But this is easy calculation, and we can do that. But does it mean that you have to create a new data to do that calculation and save it again? No. What we can do those kind of math on the fly and apply. So if you're looking at the temperature in Kelvin, but what you are actually presenting is it centigrade or Fahrenheit. And we can actually do a lot more with on-the-fly analysis. That's why raster function is very powerful, right? And we also have Python package, which actually lets you expand your analytical capability and read-write netCDF file. We have created some sample tools. There are many more out there that you can use, and we do it, other people do it, and it's out there. There are community that creates lots of tool like MGET toolset. They have like more than 180 toolset. Australian Navy, they created, many other agency creates it. We don't have them, but I know they do. Right. With that, I'll hand over to Sharmishta again to show you how to do some analysis.
Cool. Thanks, Norman. Now let's see how we can visualize and analyze within ArcGIS Pro. So I have this 100-year precipitation data of the United States. And I want to look how it changed, how the precipitation changed over time. So to do that, I'll enable time slider. So from properties, I'll go to time. And I'll set this layer has time as dimension. I know that, so that is set as my layer time. And time is specified as the time dimension. So that enables my time slider. I can change the slices, or I can also animate through it. Similarly, if I have any other dimensions besides time, say for example, in this example, I have depth as a dimension. So here, if I want to see how water temperature, the mosaic in the mosaic earlier, we created water temperature. So if I want to see how water temperature changes with depth, I can use the range slider. To enable range slider, I'll go to the properties pane. And here I've already added standard Z, which represents depth for this data set as my range. This enables the range slider. Again here, I can step through all the range slides, all my depth slices, or I can also animate through it. Isn't that cool? But before, I have shown you how you can see the change in precipitation over the whole of United States. Now, what if I want to specify a point and see how the precipitation changes in that location for the last 100 years? So let's choose a location where we are right now, select something like Palm Spring. And I'll do that using a temporal profile. So I'll select my location. I set my time and the variable, which is precipitation here. And as soon as I do that, I get my time series. This shows how precipitation has changed over time for the last 100 years. Now, if I want to see a different average, say, for example, I want to look at how the 10 years average is, I can easily change my interval size, and I can aggregate that using mean. I can also, in this case, I can also select more than one point and see how it has changed over time. Similarly, if I want to probe at one given location, all right. Okay, I got some error.
Ah, that's the real demo, right?
All right, let's see here. So if I want to probe at a given location, and for depth, I want to see how the depth slices are and how water temperature is changing with that, I can extract all the values from the depth slices using a sample tool, which is a spatial analysis tool. And I will use it as, I'll process it as multidimension to get all the slices. So the output from the sample tool is a table, which looks like this. And from the table, I can create a scatter plot, which can show me, like how the water temperature is changing with depth. Now that is all about this cool visualization thing. Now what if I want to do some analysis with my data? So in this data, I have a 100-year maximum monthly temperature, and for all months, and I want to see the mean for, say, like the month of June. So here I'm writing a script. Where I'm interested in the Tmax variable, and I want to create netCDF raster layer for all the 100 rasters, for all the 100 raster layers for the month of June. So I'm selecting June, and I'm creating a for loop for it. I'm setting all my raster layers output to this layer, to this list, and I input that list in my cell statistics tool, and I calculate the mean. And this is how I get the mean for the June month. I can do hundreds of different analyses using various ArcGIS geoprocessing tools that are out of the box. However, in some rare occasions, I also do come across a situation where I have to, I do not have an out-of-the-box solution. In such a case, I have to write a script tool for myself. So for example, in this situation, I have this chlorophyll A raster. And as a marine scientist, I would like to look at the edges where, I want to look where they are located because these are important places for fisheries. And I want to detect those. So to do that, I've written a script tool. So this script tool looks like any other geoprocessing tool. So it inputs a raster. It has some parameters, and I'll output to a polyline. So while this tool is running, let's look at how my script is actually. So in this script, I'm defining the name of the tool and the input and the output parameters, which are standard for any script tool. What I'm specifying here differently is I'm importing ND image and signal from the Scipy package, because this is where I have the edge detection functions from. The edge detection functions takes in an array. So I'm creating a raster to numpy array. I'm converting my raster to a numpy array. I'm performing my edge detection here. And then I'm saving my array to a raster. Finally, I'm creating a polyline from that, and I'm smoothing that polyline. This is what my calculation is. Now let's see if this is completed. So this is still running, and you can see it's creating 19,700 edges. So it might take some time, but this is how my edges are going to look. So if we take a closer look, this is how it is going to detect all the edges. So in this way, you can visualize and analyze within ArcGIS. And if you need something specific, you can easily create that using various Python packages and consume that as a script tool. Over to you, Norman.
Thank you, Sharmishta. So over only slightly 7-8 minutes, Sharmishta has showed you so many different things you can do with scientific data, the multidimensional data, right? Doing that calculation over 100 years for the month of June, it was, first you think about it and say like, okay, I don't have any tool, how do I do that? And then if you step back and say, oh, I have a tool, cell statistics, that does the average, right? So my only challenge is to how can I actually create all the slices and feed it into that tool. You just write a simple loop, put it in a list, throw it in cell statistics, voila, you get the result, right? Even doing the edge detection, right? We don't have that tool, but how difficult was it to actually use a third-party solution and create a geoprocessing tool out of it? Not that difficult at all, actually. And and of course, it does not take raster as input. It works with array, numpy array. So what? We have way to change raster to array, get it done, bring it back, save it as a raster, and then run all other operations like polyline and smooth line. There you go. You actually have a perfect solution for your problem, right? So that is always encouraged, and I always encourage you to step back and say, okay, your problem looks a little complicated, but break it apart and see what the tools we have and what we don't have, and see if we can combine them together and come up with a creative solution, right? And these are a very powerful solution. Now, after you have done all the nice, cool work, of course, you want to have the bragging right. I'm just kidding. But you want to share with the community, right? Because, it is so powerful, and there are many ways to share. And in our platform, we can actually disseminate data very easily. And going back to our platform story, of course, we have server where we publish content. Somebody is accessing from there. Everybody is working on it. And most importantly, with our architecture, we can use multivariate multidimensional Mosaic dataset, which can be updated on a regular basis. So if you are getting new data or model simulation result, you just update it frequently. And I'm talking about like hourly update. I'm not, or something like that. Model outputs are very frequent, right? Anyway, so let's go through this really quick here. What is the simple way to do it? Once you have a Mosaic dataset, you're gonna share as web layer. Right click, and there you go. You specify some parameter, and then you can share it. Oh, wait a second. You have clients who actually supports OGC standard. They don't like ArcGIS services, right? They just read OGC services. Fair enough. You can actually go and check those boxes, WMS, WCS, and when you are publishing image service or map service, you are actually creating those services also so that they can consume. So not a problem. Okay. What are the way we can actually share? We can share map service, image service, and geoprocessing service. Now, one important thing, if you try to deal with this problem before, where you have information changing over time, or not depth, what did you do? You may have to create different slices and publish all of them, because somebody over there sending in a request and WMS and then actually trying to get the slice. We don't have to do that anymore. What we can do, we can publish one layer and enable WMS, and from the client side, we can send the request to get the slice we want. Basically, our WMS service is actually multidimensional. It supports the time keyword as well as elevation keyword, right? So it's actually much powerful than it looks like right now. Here's an example that what are the things we are doing with it, or our customers, organization who actually use our platform. Hard data, high resolution, rapid refresh weather model, 3 kilometer resolution, hourly update, tons of data, right? So when we actually create this solution and show to some of our NOAA friends, they were like, what? You are consuming hard data? It was a really impressive thing for them, and it was fun for us. So you can actually create some of this workflow easily and publish ton of data, right? And once you have the data, what are you going to do with it? Of course, you want to do something with it, right? You want to consume it. And where can you consume? You can consume in any client or in any ArcGIS application, in a web map, or you can create web-based application like configurable apps, story maps, use web app builder to do your another app, or you can write your own dashboard or application using ArcGIS API for JavaScript, right? Here is some of the ways we actually consume this information, right? See, here's all this industry solution. We have app templates that you can use. You can go to app builder and actually build your own app. You can use workflow apps, Python API, story maps. There are so many ways to go about it, right? The possibilities are actually endless, right? Here's an example that after we actually published that hard data, we actually created this app which we call HRRR Explorer, where you can see all the different kind of data. You see some kind of it looks like a probe. You can see all the values and a different symbology over there for wind, right? So you can build anything you want, right? Now, nowadays we all understand that we have to unlock the data. Just keeping it on our desktop and doing some work is not good enough, right? So with that thing in mind, last couple of years, I think from 2013, we started to publish a lot of data. And now we all know about Living Atlas. We didn't do that before, actually, right? So Living Atlas, where we actually publish authoritative data, right, curated data, and in one category is Earth observation, where you can see all sorts of multidimensional data, scientific data, right, that we show, right? Some of the examples are, let me see, why it's not changing. Oh. Okay. So some of the services we have is Moody's data service, right? Live NOAA wind service, NASA global GLDS service, and many more. We are adding more and more, and these are all great example, not only that for the data you have there, but how we go about it, publishing this kind of data and updating. These are all good best practices. So when we talk to different organizations, and they ask me, how do we do it? I said, okay, let's take a look at what we do for that data or this data. That's discussion always going on, and it's useful discussion. And scientific data, combining scientific data with other non-GIS data to do something useful is very interesting. Right? And when you do that, you can write about it in story map and actually explain people and your community that the impact of it. So there are many ways you can disseminate. Giving a netCDF file to somebody is not going to do any good. It's not useful. Okay, so some key information that you want to kind of remember once you leave our session. Mosaic Dataset is a robust data model, right, that allows you to manage huge data, and I'm talking about huge data, right? I'm not talking about your one file, two file. But hey, if you have one file, two file, you don't have to create Mosaic, so that's cool too, right? Raster function is a very cool, efficient way of doing analysis on the fly and create information product. Like you want to combine two different variables and create a third information. Wind chill is an example of that, where you have to look at the temperature, velocity, and all those things and combine together, and you get a new information, which is wind chill, right? Mosaic Dataset is a very quick way to publish data, right? You can actually create a live web service out of it very quickly. She will show you how to do that. And then, if you have a workflow, right? Usable and repeatable workflow, you can actually share that with a larger community through Mosaic Dataset by publishing and doing it. So the point here is that ArcGIS is a scientific collaboration platform. If you think of this way, you can do a bunch of stuff. You can get all this data, and then you can analyze, and you can create rich information product, and then you can disseminate whatever way you have. Services, files, and then it is available to everybody. Somebody can consume, somebody can contribute. Now this whole cycle is going on. So it can become a complete platform for scientific collaboration, and that's what we're hoping for, right? Bring in everybody. And with that, I'll hand over to Sharmishta to show you how it works.
All right, thank you, Norman. Now that I have visualized some good data, I would like to share that with my user group and colleagues so that they can do some analysis with it. So to do that, the first step will be to publish my data. That's how I share it with everyone. So we have already created this HiCom dataset, this HiCom Mosaic dataset with water temperature variable. So I'll right-click on that and share it as a web layer. While I'm doing this, I should have access as an admin or a publisher to publish this dataset. So I already have a name. I give it a summary and a tag. And depending on with whom I want to share this, I can share it with either everyone or with my user group. From configuration, I want to enable WMS and WCS so that third-party clients who supports OGC standard can consume this. Now I'll go ahead and analyze the publishing. Here I have two warnings, which I can ignore for now, and I'll go ahead and publish this. One thing I'll mention here is at an organization level, we often have to publish more than one data set. And it is helpful if we can automate the process because we have to do it very often and it's always good to do this. So we have this help page, which you can take a look. And this is an example of how you can publish more than one data set, and you can go through this to see how to automate this. So to save time, I've already published this. And to consume this, I have to log into my portal. This is now my portal item, the HiCom water temperature. And I can go and add this to the current map. And this is how it looks. It looks exactly like any other raster layer. So how do I know this is a portal item? I can go to the properties of this. And in the source, I see that it's coming from my portal. Also, since it's published as a multidimensional data, it does have time and range enabled already. So the things that we have visualized before, we can do this with this data set. Now, since I have this data set, and as a marine scientist, say, for example, I'm doing a habitat studies, habitat analysis, and I want to look at the areas that are within 15 to 25 degrees centigrade and of water temperature, and I want to see where those locations are. So I want to do isotherm of this location. So to do that, I can use the contour list tool. Where I'll input this Mosaic data set, and I specify my contour values. I'll run this tool, and this is how my output would look. So it took an image service as an input, and then this is how it looks better. So I symbolized it nicely. So you can use any geoprocessing tool that actually takes an image service as an input. So with that, you can do a lot of analysis with this consumed data. Another thing that I would like to mention, that you can see all these videos and lectures available in our Esri website. So you can go there and see all these presentations from there. So this is how we can consume and publish scientific data set and do analysis on them. So over to you, Noman.
Thank you, Sharmishta. So she earlier created a Mosaic data set, and she demonstrated how easy it was to publish it. You just go in catalog, right click, and say share as web layer. There you go. If you have connection to your server, you can publish it just like that. Now once you publish it, consumption was also easy. You just go find it, add it, and then you see you can actually use time slider on it, you can say range slider on it, and on top of that you can do analysis with it. And the tool that we used here to do isotherm is what? Contour list tool. That tool is available for how many years? Way long, right? So the point we're trying to make again and again that we have lots of tools in the toolbox. You just have to connect the dot, right? You use this tool and use this data to do all sorts of analysis that you can do. You don't have to have a multi-dimensional analytical tool to do these jobs, right? You just have to connect them together and use it. And the reason I keep mentioning it again and again, that first couple of years, around 92, 93, when we were presenting it, we're talking a lot about scientific data and what is happening under the hood and how we can do analysis. And some people were not really getting it, that you can not only read, you can do a lot of analysis with it. So we actually change our way of communicating this. Now we do a lot of demos so that you can see that, hey, we have all this tool, you can actually use it with scientific data as soon as you read it, and then you can use it the way you want, right? Now, with that, I have to mention a couple of things. We have a few more minutes left, and before we go for questions, I want to conclude with some simple statement here. The challenges with this kind of data is standard. If you ever try to get some data, from download from NOAA or NASA or some other agency, and one data work this way, another data work that way, that is always a challenge, right? To say the least. So if you are in a position to create data, then please pay attention to that. Embrace common data model and use data metadata standard like OGC CF so that your client, the client that you're using, the application that you're using, it can use your data. Now, it may not seem very important immediately because on many occasions you will write the application to create the data and you will also write the application to read the data. So of course you know what you have written, you can read it. For people like us who are writing application from this side, very difficult, right? And somebody else, very difficult. So it is important. Please produce and use CF compliant data. The more we talk about it, more the awareness actually increases. It's been almost like a journey that even though when we started with CF convention, people say, oh, it's a great thing, but I couldn't even find data that actually CF compliant. Sometimes I manually created data that are CF compliant to test it, right? But now things have changed. Many organizations are open to it. They have changed their data. They have added additional information so that they are CF compliant. And there is a CF compliance checker actually out there, out of UK, and you can use it and check whether it's CF compliant or not. Make your data special. If you don't have this projected coordinate system information, then bringing in GIS is not going to do much because you won't be able to combine that with any other data set or do anything with it, right? Then use our tool to do your work, but then when you actually hit the roadblock and want to do something unique, create your own script tool and then do the work like any edge detection, right? And then if nothing works, and you say, it's all Norman's problem, make it Norman's problem, Sharmishta's problem. Okay, reach out to us. We are listening. Tell us what you are trying to do. Define your workflow, define your requirement. If you have been watching our progress in this area, we have made some significant changes over time, and especially last couple of years, we are going full speed ahead. And in the future, it's a sneak peek. We're trying to do, you will see a lot of tools actually process multidimensional data. She gave you an example like sample tool. That tool was there for many years. We just added one little thing, said that, process as multidimension, which means which used to work with simple raster now work with a hypercube. So we are actually under the hood changing and doing a lot of stuff, right? You just have to look at it closely and see how we are supporting scientific data, multidimensional data all over the places, right? And so new changes are coming, new functionalities are coming, and if you need something, just reach out to us, let us know the workflow, the pain, and whatnot, and we'll look into it, okay? With that, I'm going to open up for questions. Any questions? Yes, sir.
data
Yes.
is take a series of points or a polygon that has a set of points within it and do that time series graph with air, from like take a mean line and then the air around it. Is that something you're considering in the future where you can actually average a series of points in an area and do the time series graph that way instead of one point at a time?
Actually, it's interesting. So the question was, I'm paraphrasing, that can we take multiple points and actually do average over the area and then the time series of that? In Pro, we have actually a layer type where you can actually define some of the query and you can do some of this analysis on the fly, not only for individual point, but you can actually summarize them over the area and also do time series or moving average and things like that. So I'll give you my card, reach out to me, I will point you some of the data. So the trick is here, right? You have to bring this scientific data in a situation where we can apply those tools and to do it. But we do have actually really cool tools that do all those things on the fly. We have geoprocessing tool that will create output. Now there's another thing that I want to mention that you will see in Pro and everywhere else, we are doing a lot of data exploration tool. So we have geoprocessing tool, analytical tool that create persistent data, but sometimes you just want to explore and see how it looks, right? Before even creating the data. So you are doing a lot of map exploration kind of tool, layer and other tool to actually visualize it and before you can even create and process the entire data set or thousands of data set, right? Yes, sir.
So we are trying to map eagle migration patterns in wind turbine locations. And we're actually using the probe data from the actual telemetry eagle data. And we can try to find out, depending on the wind speed directions and temperatures and humidities, and then how these telemetry data are responding to those variables. What are the most important variables that decides the eagle to go one way or the other?
Yep.
So to do that, I was thinking about using ArcGIS to create data frame with the geodata. I mean the XY coordinate, and convert to netCDF data. I'm not sure. What's the best way to go about?
Well, this is a very loaded question. You are trying to do some kind of analysis, combining different variable and find a suitable path or see the relationship, So we have many tools to do this kind of thing. The real problem coming is that where is the data coming from and in which format? And so the question is, and how to convert this data to something that we can consume. Now, whether this data has to be converted to netCDF or not, that is actually an important question mark because we may not have to do that. But if you want to do that, of course you can use a couple of things. If you can create a raster or feature and then convert it to netCDF, or you can use netCDF for Python API to write it. So there are many ways to go about it, but listening to your problem, and we can discuss that separately, you may not need to create netCDF file at all. We are also part of Spatial Analyst team. I work for Spatial Analyst team and Geostat team. So everybody, when I start doing netCDF, say, oh, now I'm going to take all my raster to convert to netCDF. I said, no need, right? The objective was to support netCDF, not to move your perfectly fine data to netCDF, right? There's no point of doing that, right? Okay, any other question? Okay, thank you very much for attending this session. Thank you.